All right, guys, you know the rules or the what we're going to do. I'm going to go through the notes. It's pretty quick, and then I will break down the workbook. It'll probably be its own little video. I'm also going to put the links into the actual videos because on this one, the Eureka, as you watch the TED Talk that goes with it, you need to come up with 3 important facts that would help you understand how to look for density, because that's what we're going to look at today is the density of objects. Um, so to understand density, this is the three dashes on your notes. Um, when we understand density, we can look at how much matter is in the actual object itself, how tightly packed the molecules or particles are, and then the last one is the space that the object takes up. So this includes its weight, um, but looking at the space it takes up will help us understand if it's a high density or a low density object. So comparing densities is pretty simple. We look at the brick that's here, and on your notes I drew a brick and I drew a sponge, so that's kind of where I'm at in the notes. Um, the brick has a high bulk density but a low pore density, meaning that the molecules are packed really tight together and there's not a lot of space in between the molecules. If you look at the sponge, it has a low bulk density, meaning there's not a lot of mass to the actual molecules that are there, and then there's a high porosity or high pore space. So there's lots of space in between the molecules themselves. Then in the picture, so which is the heaviest or the most dense, um, the cork, so that's the first one that you'll need to fill in that little blank, is cork or wood or metal. So which one is the most dense? And you can answer that question by looking at which one sinks in the water. So the cork floats a little bit higher up than the wood. So if you look at the exposed amount of cork versus the exposed wood, so what's in the water of the cork, what's in the water of the wood, and then what's in the water with the metals. So which of the 3 has the most submerged or in the water, and that would be our piece of metal. Then the density of matter, so we look at how tightly the molecules are packed together, going back to our states of matter, of solid, liquid, and gas. With the solid, the molecules are packed really tight together. A lot of them are connected. This is where they vibrate in place. With the liquids, there's a little bit more movement to them, and then gas, there's a lot of movement to them. Our density example, so to think about how molecules are packed together, because most of us can think of shopping carts. In shopping cart A, or object A, the fruits and vegetables that are there are more tightly packed together. There's less space in the shopping cart. Where if I look at object B or shopping cart B, there's a lot more space. I can fit more things into B. So if I'm looking at these 2 shopping carts, cart A has a higher density than cart B. You have this formula in your notes. It's at the bottom of the first page. So the D stands for density. So these are the little boxes around the formula that you're going to fill in. So the D stands for density. The M stands for mass. V stands for volume. And then in the triangle, we're going to put the same letters. You don't have to write the words in it, just the letters. So if I'm starting at the bottom left of the triangle, D for density, V for volume, M for mass. So in math, when we do these triangles, if they're next to each other, then I multiply. If they're on top of each other, then I'm going to divide. And then we will look at a sample of this in just a second when we do our work through the water displacement of it. So with this picture, or with this slide, if I know that the mass of the object is 120 grams, the volume of the object is 5 milliliters, I would divide 120 by 5, and that would give me 24 grams per milliliter. So the density is the mass divided by the volume. So you have, we have this already in our notes, so you don't have to recopy this. Again, looking at the cork versus the rock. So the cork has less density than the rock does because it's going to float. This is the practice one that we're going to do. So when we solve for density with what they call water displacement, we have to get the volume first. To get the volume first, you have to look at the two graduated cylinders and look at the differences in the water. So in the first one, it's about 17 milliliters, and then I put this random little rock in it, and it goes up to 20. So if I take 720 and I subtract 17 from it, gives me 3. So on your notes, next to the V, you would do 3 ml, and that's going to be our volume. So then I show you here what I did, right? 20 minus 17 gives me 3 milliliters. The mass of the rock that they gave me is 18 grams. So then my equation is the mass divided by volume, which would be 18 divided by 3, and that gives me 5. Nope, 6. I can math. Hold on just a second. If you have to leave, I need you to clean your space yourself. If you are staying, then just hang tight. So then on this one, there will be another video that I give you guys in just a second that has me walking through these because I'm going to need a separate piece of paper to do these. So again, the mass divided by volume tells me that the mass is 10, volume is 5, so 10 divided by 5 will give me 2 grams per milliliter. Then on this one, again, mass divided by volume. So I have 16 grams. My volume is going to be 4 because it went up by 4 milliliters. So 16 divided by 4 gives me 4 grams per milliliter. Okay, so